So now this video is integration of natural log. So we already reviewed derivatives, which I talked about. I've already shared with you how to do derivatives of natural log earlier in the semester. So that was more of a review. So this is all new. So on this, we're integrating our natural log. All right, so in order to integrate natural log, remember the derivative of natural log of some function is f prime over f. So the question is, can you integrate f prime over f? So you want to do that. You want to be able to recognize going backwards that you have the derivative on the top and you have the function in the bottom. That means it's going to be the natural log of f of x, and we have to put it in absolute value bars. All right, and then the simplest one you can do is 1 over x. Okay, so the integral of 1 over x is natural log of the absolute value of x plus c, and this would have a plus c on it too. All right, so let's integrate this problem. So when I'm looking at this first problem here, I'm recognizing it as this one, 1 over x, but it's been doubled. So I could move the 2 out in front. So it's 2 times the integral of 1 over x dx, which means it's 2 times the natural log of the absolute value of x plus c. Over here, what I want is I want to have the derivative of the function on the bottom in the numerator. Well, the derivative of 4x minus 1 is 4, and there's not a 4 up here. So there's 2 ways to do this problem. You can do u substitution, which is what a lot of students do. They let their u, let's see, I'm going to change the color. So they let their u be the denominator, 4x minus 1. So du equals 4 dx, because remember you take the derivative. And then I solve for dx. So I'm going to divide by 4. So that would be du divided by 4. So now I'm going to come over here and trade out. So this is going to be 1 divided by, okay, in place of 4x minus 1, I'm going to put a u. So I'm going to put a u here. And then in place of the dx, I'm putting du over 4. Right? So now remember, I always had you put them in order. So we put our fraction first, which is 1/4. And then we put our function, and I'm going to leave it 1 over u because now we know how to integrate that. And then my bookend du. So now when I do the antiderivative, I keep my fraction 1/4. We know the antiderivative of 1 over u in u's, that's going to be the natural log of the absolute value of u plus c. And then we just put our u back in. We put our, what we said u was, our u substitution, we put it back in. So that'll be 1/4 the natural log of the absolute value of 4x minus 1 plus c. Now, here's what I want you to notice. When I was looking at this problem up here, the function on the bottom is 4x minus 1. If we had, if the derivative, which is 4, if this was a 4 up here, we'd be in business, right? Because we'd have the derivative over the function. All right, well, if I want to make this a 4, I can just multiply this function by 4 as long as I put a 1/4 out here, because then that would cancel. So I could multiply this by 4 if I wanted to, if I put a 1/4 out in front of the integral, because now that cancels and it still gives me 1 over 4x minus 1. Now, this derivative here, I mean this function here, 4 over 4x minus 1, that's the natural log of 4x minus 1's derivative, right? And then here's the 1/4. All right, so you can do some of these things mentally if you're really good at seeing what the derivative, what this needs to be in order to be the derivative of the natural log of 4x minus 1. It needs to be 4 over 4x minus 1. So, I mean, you can do some little tricks like that. It doesn't always work, but you can do little tricks like that. All right, most of the time you want to do a u substitution, and you want to look and see if your derivative is on the top, okay? So when I'm looking here, let's see, the derivative of this denominator is going to be 3x squared plus 1. That's exactly what's up here. So I know this problem is the natural log of x cubed plus x plus c. I already know, I mean, that's easy because the derivative of that is in the numerator. So that one's an easy one. Same thing over here. The derivative of tan is secant squared. So I know this is the natural log of tangent plus c, because the derivative of this would be secant squared over tangent. All right, because on both of these cases, we had f prime over f in both of these examples here. All right, so that means the answer is the natural log of the denominator plus c. So those are easy ones. All righty, now integrate this one. Well, to do this one, I can either think of, okay, well, that's the one that was on that chart, right? I already know what that one is because it was in the little chart I gave you that you're going to memorize. But what I want to show you how they got that answer. So what I'm going to do is I'm going to rewrite tangent as sine over cosine. Okay. All right, so I'm going to write it as sine over cosine because we know the tangent function is your y over your x, your sine over your cosine. So now I'm going to do a u substitution. So u is going to be my denominator, cosine x. So then du is going to be, derivative of cosine is negative sine dx. And then I'm going to divide by negative sine. So I have du over negative sine x. So now I'm going to come over here and trade out. So I'm going to have sine over, okay, I'm going to replace cosine with the u. And then I'm going to replace the dx with this. So I'm replacing dx with du over negative sine. So you'll notice the signs cancel. So I've got a coefficient of -1, and then I've got 1 over u for my function, and my bookend is du. So now when we do our antiderivative, not that difficult. All right, we've got a coefficient of -1. We know the antiderivative of 1 over u in terms of du. That's going to be natural log of the absolute value of u plus c. And then I'm going to put my u back in. So since u was cosine, this is going to be -1 natural log of cosine plus c. And if you look in that chart on page 329, that little table or box or whatever you want to call it that's in the book that has all those trig integrals, the integral for tangent was negative natural log of cosine x plus c. All right, so that just shows you how you get that. But this is one of the ones that you need to memorize in that little chart I gave you. And you can look them up on page 329, write them in your notes. Those are ones you need to know. All right, number 13, solve the differential equation. So we're going to solve this equation. You know the process of how to solve a differential equation. We need to multiply the dx over here. We've done this before. So we multiply the dx over here. So I have 1 over x ln of x dx. So you multiply your dx over, and then we're going to integrate on both sides. Okay? So the antiderivative, this is a 1 right here. So the antiderivative of 1 in terms of y is going to be a y. And then on this side, we need to do a little bit of work. So what you notice is we have a 1 over x, and you also have natural log of x. Well, the derivative of natural log of x is 1 over x. So I'm going to do a u substitution. And I'm going to let the u be natural log of x because I see his derivative 1 over x in the problem. So du equals the derivative of natural log of x is 1 over x dx. And then I solve for dx by multiplying the x to the other side. So now I'm going to trade out here. This will be 1 over x. In place of natural log, I'm going to put a u. And then in place of the dx, I'm going to put x du. So you will notice that the x's cancel out, all right? And you just have the integral of 1 over u du. And I know the antiderivative of 1 over u du. That's the natural log of the absolute value of u plus c. So now all I got to do is plug my u back in. My u was natural log of x. So that's going to be the natural log of x plus c. There's my answer. All right, so I did a u substitution. We're starting to get a whole bunch of things that we've learned here all in one problem. So we've learned how to solve a differential by moving the dx to the other side and integrating both sides. We've learned how to do the antiderivative of 1 over u, which is natural log. We've also learned how to do u substitution when things are a little more complicated than just power rule. So we are incorporating in that problem several new things that we've learned recently. Find the area bounded by the graph. Let's get rid of that bar on the bottom. There we go. Find the area bounded by the graph of y equals x over x squared plus 1, which is this graph. The x-axis, okay, so the x-axis is here, and the line x equals 3, which would be a vertical line at 3. So this hits the origin at 0. So I'm finding the area here. So find the area bounded by this graph, the x-axis, and the vertical line x equals 3. So I'm wanting to find this area. So we know to find the area under a curve down to the x-axis, we're going to do an integral. We're going to go from 0 to 3 under this function, right? So this function is x over x squared plus 1, and then we need our bookend, dx. So there's our integral. So now we just have to do the math. Let's do the antiderivative, and then we'll do the fundamental theorem of calculus, right? All right, so we need to use what we've just learned about how to do the antiderivative of this. It looks like a natural log problem because the derivative of x squared plus 1 is 2x, and I have an x up here, I just don't have the 2. So I'm going to do a u substitution. I'm going to let u be the denominator, x squared plus 1, because his derivative is almost in the numerator. We're just missing a coefficient. So du is going to equal 2x dx, and then I solve for dx, so I'm going to divide the 2x to the other side. So now I'm ready to trade out. So this would be x over, in place of x squared plus 1, I'm going to put a u. So I'm going to put a u there. And then in place of the dx, I'm going to put du over 2x. So you will notice the x's cancel. So let's write our fraction first, which is going to be 1/2. Let me make that neater so it doesn't look like 1/3. So 1/2. And then we've got a 1 over u. I'll just leave that 1 over u because we know his antiderivative. And then our bookend du. Now notice I did not put the 0 and the 3 down here. Do you remember why? All right. The 0 and the 3 are x coordinates. And I've changed everything over using u substitution. I've changed everything over to u's. So what I need to do is I need to put my new numbers here. So this used to be a 3. So now if I plug 3 in here, 3 squared plus 1 is going to give me a u value of 10. And then if I put a 0 in here, 0 squared plus 1 is going to give me a u value of 1. So now my integral is going from 1 to 10. All right, so let's do our antiderivative. So we keep our coefficient. The antiderivative of 1 over u is natural log of u. I don't need the plus c because now I have limits of integration going from 1 to 10. I also don't need to plug the u back in. Don't put the x squared plus 1 back in unless you go back and use these numbers 0 and 3. All right. So now I'm going to do the fundamental theorem of calculus. So I'm just going to plug the top number in first. So that'll be 1/2 natural log of 10. And then I'm going to plug the bottom one in, subtract, and then plug the bottom 1/2 natural log of 1. All right. So now we know that the natural log of 1, that's 0. So this part's going to go to 0 because natural log of 1 is 0. So my answer is 1/2 natural log of 10. You could also write that as, move the exponent, right? Natural log of 10 to the 1/2. You could also write that as the natural log of the square root of 10, right? So all of those are equivalent. If it was a multiple choice question, any of those, natural log of the square root of 10 or 1/2 natural log of 10, either one of those would be a plausible answer for a multiple choice question. All right, so you should be able to get from your answer 1/2 natural log of 10 to recognize that that's the same as the natural log of the square root of 10. So you've got to have enough of those skills to be able to find the correct answer on multiple choice. All right. Or it could be a decimal question. And if it was that, then we would have math 9 to this problem up here from the beginning, right? We would have done math 9 on your calculator, typed all this into our nice little pretty font on our calculator, and pressed enter, and it would have given us the decimal equivalent of whatever this is, the natural log of the square root of 10, whatever that actual number is. All right. So that was finding the area bounded by the graph of those three things, and I did the fundamental theorem. So we're just practicing all of our skills that we've learned. We've learned so many things. All right, this one says evaluate the integral from 0 to pi over 4 of the square root of 1 plus tangent squared x dx. All right, well, the first thing I know, and this is where most people get caught, I know that this is an identity. 1 plus tangent squared, that's secant squared. That's an identity. That 1 plus tangent squared x is equivalent to secant squared. Then you'll notice that you can take the square root. So the square root of secant squared is just secant. So now we're to a problem that is in that table or box on page 329. Those trig ones that you have to memorize. So the antiderivative of secant is the natural log of secant plus tangent. I don't need the plus c because I'm evaluating from 0 to pi over 4. So now I'm going to do the fundamental theorem of calculus. And I made my parentheses big because I know I'm plugging in a lot of stuff. So I'm going to plug in the top number first. So I'm going to do the natural log of the secant of pi over 4 plus the tangent of pi over 4. And then minus, and then I'm going to plug in the 0. So then I'm going to do the natural log of the secant of 0 plus the tangent of 0. And so now I need my unit circle to figure out what these answers are. So this is the natural log of whatever the secant is plus whatever the tangent there is. And then the natural log of whatever the secant of 0, whoops. Whatever the secant of 0 is, plus the tangent of 0. I don't know why I did all those parentheses, but I just got it set up for us. All right, so I need the secant of pi over 4 and the tangent of pi over 4. So on the unit circle, pi over 4 is in the middle of the first quadrant. Our coordinates here are radical 2 over 2 and radical 2 over 2. I need the secant. Well, the secant is the reciprocal of your cosine, and this is cosine sine. So the reciprocal of cosine, which is turning this upside down. So that would be 2 divided by radical 2, which is radical 2. Then I need the tangent of pi over 4. All right, so the tangent of pi over 4 is sine divided by cosine. So that's going to be radical 2 over 2 divided by radical 2 over 2, which is just 1. All right, then I'm going to need the secant and the tangent at 0. So here I am at 0 on the unit circle. That's the ordered pair 1, 0. So that's your cosine and your sine. So the secant at 0 is the reciprocal of 1, which is 1. And then the tangent of 0, the tangent is sine over cosine, so that's 0 over 1, which is 0. All right, so I just did the unit circle and my ordered pairs to evaluate all 4 of those trig functions. So now looking at this simplified, this is going to be the natural log, and I don't need the bars because this is a positive number. This is radical 2 plus 1, that's a positive value. Then over here we have minus the natural log of 1 plus 0, which is just 1. We know the natural log of 1, that is 0. So our final answer is the natural log of the radical 2 plus 1 of that quantity. So there is the answer for the value of that integral. And if you math 9 to this, then you could also type the natural log of this quantity in your calculator and you get the same answer. All right? So that is the area underneath this function, square root of 1 plus tangent squared, on the interval from 0 to pi over 4. The area between that function and the x-axis is the natural log of square root of 2 plus 1, whatever that value is. Okay? All right, let's see what else we got for us. Oh, yeah, this problem. All right, this problem involves kind of a trick. Typically, you're going to divide this longhand. All right, you're going to do this longhand. You're going to do x squared plus x plus 1. You're going to divide it by x squared plus 1. All right, this one you can kind of see what the answer is because I see x squared plus 1 in the top, and then this is x squared plus 1 in the bottom. So I know this is a 1 unit plus x over x squared plus 1. I can break it up. But you're going to get the same thing if you do long division. If you take your numerator, put it in the house, your denominator, put it outside in the divisor spot. Now divide. X squared goes in x squared one time. All right, so then you multiply x squared plus 1, then you subtract. So x squared minus x squared goes away, 1 minus 1 goes away, you're left with x. So that does not, x squared does not go into x, so you're left with your remainder x over x squared plus 1. You always put your remainder over your divisor. So this is the same thing as 1 plus x over x squared plus 1. And that's what I was talking about, that you can kind of see that in this problem. This is kind of an easier problem. I see an x squared plus 1 in the numerator. So that's my 1, that's my whole 1, and then I have a remainder of x left, x over x squared plus 1. So this one was kind of an easy one to kind of see where it was going to end up going. So now I'm ready to do my antiderivative. All right, so the antiderivative of 1 in terms of x's is going to be x plus, and then this one I might need to do a little bit of work because it's x over x squared plus 1. So this might be where I might do a little bit of u substitution, or I could use an idea that what's the derivative of x squared plus 1? Well, that's 2x. Well, I've got everything up here but the 2. So this is actually 1/2 the natural log of x squared plus 1. I mean, I just did that in my head only because I almost have the derivative up here in the top. If this was a 2 right there, we'd be perfect. So that means I need a 1/2 in front of it to cancel that thought there. So I have the derivative of the function in the numerator, and then I have the function in the denominator. So that's the natural log of x squared plus 1. And the only reason I need this 1/2 here is because there needs to be a 2 in the numerator in order for this to be the derivative downstairs. But if you don't like doing that in your head like that, then you can do a u substitution. You let u be your denominator, the x squared plus 1, because that's what you do when you do u substitution. When you think it's natural log, you always let your denominator be u. So then du is going to be a 2x dx. You solve for dx by dividing by 2x's. Then you trade out. So I'm kind of doing a scratch work here for the integral of x over x squared plus 1, just that part of the problem. All right, so when I do that, it's going to be x over u, and then in place of dx, I'm putting that stuff, so that'll be du over 2x's. The x's cancel. So you'll see you've got a 1/2, and then you've got your 1 over your u, and then you've got your du. So there's where the 1/2 comes from that I have here. And then the 1 over u is the natural log of your u value, okay? So that's where ln of x squared plus 1 came from. And then all we need last is put our plus c, and we're done. So however you want to do these, you know, it's up to you. Sometimes you can recognize, get the derivative in the top and the function on the bottom, and just whatever you have to multiply by, you put it the reciprocal out here in order for it to cancel. You can do it that way. That's kind of what I think of when you do a little bit of mental integration in your head. But if needed, always do a u substitution. It will never fail you. You always let your u substitution be the denominator of the problem, and then you trade out and you be home free. So it's just going to take some practice with all this. It's really all it's going to take. All right, very last problem. Last one. Yay. Find the particular solution of this differential equation using this ordered pair. All right, so we know to solve a differential equation, we need to move the dx over. So this will be dy equals natural log of x over x dx. So I just multiplied the dx over here. Now I'm going to integrate both sides. All right. So this is a 1 right here. So the antiderivative of 1 in terms of y's is a y. Then on this one, all right, I need to think, okay, I've got natural log of x, and then I have an x in the denominator. So notice that's a 1 over x, which is the derivative of natural log of x. So to do a u substitution, I'm not going to do the denominator. I'm going to do natural log of x because I see his derivative 1 over x in the problem. All right, if you just think of that as being multiplied by 1, then there's a 1 over x in the problem, which is the derivative of natural log. So then du will equal 1 over x dx. And so solving for dx, I multiply the x to the left side. So now I'm just going to trade out here. So I'm going to replace the ln of x with a u. So this will be u over x. And I'm going to replace the dx with an x du. So notice the x's cancel. All right, so y equals the integral. If I'm just clean this up a little bit, I've just got I don't have a fraction, a coefficient. So all I've got is a u, and he is in the numerator, and then my du bookend. Oh, so this ends up being pretty easy. All right. So the antiderivative of u is going to be u squared over 2, because you raise a power, right? So you go u squared divided by 2 plus c. And then you have to plug your u back in. So my final answer is y equals my u value squared. So my u was ln of x. So that would be ln of x squared divided by 2 plus c. So there's my answer for the general solution, right? That's my general solution where I've got your plus c on there. So now we want the particular solution using this ordered pair. So we've got the point 1, negative 2. So now I'm just going to substitute in. I'm going to substitute in the ordered pair 1, negative 2. So the y is the negative 2. And then it's going to be the natural log of the x coordinate 1 squared over 2 plus c. So I'm replacing x with a 1, replacing the y with a negative 2. So negative 2 equals, well, the natural log of 1, that's 0. So 0 squared is 0 divided by 2 is still 0. So all of this is 0. So that means c is going to equal negative 2. So now I'm going to put in a c equaling negative 2, and that's my particular solution. So y equals the natural log of x squared over 2 plus my c value, and my c value is minus 2. So this is my particular solution. And that's the solution curve of this family of general solutions. This is the particular solution that hits the point 1, negative 2. So now if we plug a 1 in here, we're going to get the answer negative 2, because that's the specific equation that goes through the point 1, negative 2 on the graph. All right. So that's just reviewing, finding a general solution and a particular solution given this initial condition. All right, and so I found that equation, y equals the natural log of x squared divided by 2 minus 2. All right, so that was the last problem. All right, so you've got lots of different problems to work on. A lot of these are just finding derivatives or integrals, so it looks very intimidating at first when you look at all those problems. You're like, oh my gosh, it's going to take me 3 hours of work. No, it won't. It won't take you 3 hours to do that. But they are all good problems that you need to practice, so that's why I didn't cut any of them out. So that's your practice over this section of natural log. So the first page, 321, that's all differentiation, so that's all derivatives. And then the page 330, that's all integration. So that's all doing the antiderivative of functions that end up giving you a natural log. All right, so good luck on that, and I'll answer any questions you have during our time together.